Okay, so I'm here to talk about a project I'm working on called Eagle, which is Tcl implemented in C#. So what is Tcl? Tcl is an open source scripting language created in 1988 by John Osterhout. It's primarily designed to be an application extensibility and embedding language. And it's relatively typeless, so it's very lazy in terms of evaluating strings to whatever the type needs to be to do whatever operation is being done, like mathematics or whatever. A minimal syntax, no fixed grammar, and no keywords. So who uses Tcl? Which I keep getting asked by everyone. So here's sort of just a list of some of the companies and institutions that use it. It's used pretty widely throughout a variety of different industries. What is Eagle? Well, eagle's a bird. Eagle is an acronym. Tcl is also an acronym for Tool Command Language. Eagle is an acronym for Extensible Adaptable Generalized Logic Engine, which is just a nice acronym I came up with. It's also open source. It's an implementation of Tcl for the CLR written in C#. And it's also, by coincidence, designed to be highly extensible and easily embeddable. And I cut and pasted it from the other slide, since it's syntactically identical to Tcl, basically. Notable features: it's dynamic, loosely coupled, full introspection, uses duck typing, which is if it walks like a duck and quacks like a duck, it's probably a duck. Supports Unicode, obviously, because it's based on the framework. Tcl also supports Unicode, but in a different way. They use UTF-8. It integrates with CLR classes, native libraries, and it also integrates with real Tcl TK, just in case you would like to use them together. Supports interactive debugging, although right now you can't do it through VS. You have to actually enter commands into the interactive console. Script cancellation, which is the ability to have the application on demand cancel a running script should it get out of control or use too much resources or whatever. Supports read-only variables and commands. Typically, commands can be redefined, but the application at the C# level can dictate that that's not allowed. Interpreter-wide variable tracing, so you can set up a procedure, a C# procedure that gets called when variables are about to be modified or read, so you can kind of do custom massaging. Supports anonymous procedures and closures to a limited extent. And then also, recently I added a unified unit testing framework that can run the same tests in Tcl and Eagle for basically validating compliance with the Tcl standard. More features here. So custom commands, which is sort of the whole point of the language. So we'll talk about that more later. Commands can be added, renamed, and removed at any time, and can be implemented in any managed language. Custom math functions, which are for use with the expression parser, which handles all the mathematical expressions in both Tcl and Eagle. Supports binary plugins, which basically right now means groups of commands that are sort of in one assembly. And then also versioned packages, which may refer to a plugin or may just be a pure script package. In other words, it's just at that point it would be just a convenience for wrapping a set of scripts or a single script and having it be a versioned named entity. So you can just do package require and then the name. Also supports hidden commands, which I recently added support for. So hidden commands are used to sort of implement safe interpreter support, which is similar to safe Tcl, but different enough that it merits some explanation. Right now, custom execution policies can only be implemented in managed code, whereas in Tcl they can actually be implemented in a script. So let's take a look at the syntax, I suppose, which is very minimal in Tcl and Eagle. So the syntax of the commands is the command name is the first white space delimited word, and then followed by the arguments, which, for whatever arguments that command takes, which every command is free to interpret their arguments however they wish. So the language doesn't know until it actually calls the command that set takes one or two arguments. And so if you pass 3 arguments, it's not going to know about that until it actually calls the command. And the command will say, well, that's not right. So here's an example of using double quotes to group words together, because the parser parses on white space. And so if you want to have an argument that contains white space, you need to surround it with double quotes or curly braces. And the difference between those two things is the double quotes do not prevent substitution. So the putS command will receive the actual value of x there. But in the second example, it will receive the literal $x as part of the string. And then also command substitution is notated using square brackets. And that also does not prevent substitution. So in this case, it actually will go ahead and execute this procedure. And $x will be, the value of that will be passed as one of the arguments to the grouping proc here.
Equal will be also separate.
Right. It'll be an actual literal equal sign.
What about the comma?
Yes, that's all literal. So here's an example of hello world, basically. So this is substitution, because evaluation is done in two phases. First grouping and then substitution. So grouping determines where the word boundaries are, and then substitution performs the actual variable command and backslash substitutions from left to right. So $name will be substituted with Joe in this first example. The second example here, we will get, this demonstrates a nested command. So first this will be evaluated, clock seconds, and then clock format will be evaluated with the result of that. And then finally, the outer command will be called. And finally, backslash substitution. So these are actual Unicode character code points right here. And then here's the carriage return. And then this just denotes the fact that this line's continued. But it's interesting because if you do backslash as the last character on the line, followed by a return, it actually, the parser will join that together and separate it by a space. And so it allows you to break your lines nicely for making your scripts more readable. So Tickle and Eagle have friendly error messages. So if I call set with no arguments, it suggests that perhaps I should use one or two arguments. And if I call a command that has subcommands with the wrong one, it will suggest one of the ones that I should be able to use. Here's an example of using the CLR. So recently I added threading support into the scripting itself. So every thread gets its own script call stack. And they share the global call frame so they can sort of communicate using that as an area to store things. So as you can see, I can import system.threading. And then I can create a thread object here, and -alias basically says that the opaque handle that's returned will also be added as a command. So that allows me to do stuff like $start later on. Parameter types allows me to help select the overload that's actually used. In this case, there's a thread start and parameterized thread start have different types. And then I can pass arguments to the constructor here. In this case, thread start is a string, but it has to be converted to a parameterized thread start. So then I can actually call a method, start foo. And so this foo ends up being one of the arguments to the thread start routine. And then as you can see, I'm just waiting for it to terminate and then unsetting the value. And when you unset the value of a variable that contains an opaque object handle, those are reference counted, and so it will try to dispose the object if it implements iDisposable. Otherwise, it'll just go ahead and remove it from the interpreter.
Thread start reference. How the parser distinguishes from actual execution and reference to the function? I mean,
the parser doesn't distinguish.
No, I mean, but then whether the thread start should be executed immediately before the call to object create or set.
Oh, this is just how the thread object works in .NET. So you create the thread object first, and then you call start on it. That's just how they.
Yeah, but as far as I understand, thread start is a worker method for the thread. Yeah.
Right. That's the routine that gets called when the CLR creates the thread.
Yeah. So, but you're passing the method name there.
This is not a method. This is a Tickle procedure here.
Yeah.
So And this gets wrapped in a special object that has the actual delegate, and it passes that delegate off to the CLR.
I understand, but in the SQL syntax, we had seen before this group method, it was also kind of referenced without parentheses and so on. So I mean the distinction.
Oh, I see.
Immediate
These are all strings. So at this, when I call object create, the object command gets a bunch of strings, and it has to interpret those based on the semantics of it. It knows its own semantics basically. So it's very lazily performed. Here's an example of something more entertaining. So if you'd like to call a native library from Eagle, this is sort of modeled after what's done by Fiddle and other similar functionalities. So basically, you can declare a function, and you can do it in one or two steps. You can actually specify it without the name and just the return type and parameters, and then bind it later. Or you can do it all in one call, like I'm doing here, and then you can actually go ahead and call it.
So just kind of to understand the same question. So this set here. This calls set, and then set is going to evaluate that block.
No.
And assign
So,
X.
not exactly, no. So what happens is the set command is the outer command here. And so the library command is going to be evaluated by the parser first, and then the result of that will be put in place of the second argument to set. So it will be set X, and then some opaque handle that's returned by library declare,
Okay, so
which is a string.
in that other example that he was showing, what if you wanted to call thread start instead of pass thread start as a method? Would you put it in square brackets?
Yes. Yeah, that's the command substitution I talked about earlier. So when it sees those square brackets, it's nested command invocation. So here's just a really quick example. I just want to gloss over this because it's not that important for this particular audience. But you can use real tickle tk from Eagle, and the way you do that is via the tickle command in Eagle. So it dynamically will select a tickle library to load based on whatever the highest version it finds available is, and then you can create interpreters. And this demonstrates the deep integration that it has, because it adds a command called Eagle in the tickle interpreter that basically magically jumps over to the eval command in Eagle and then executes debug break. And so I'll show that during the demo. Yeah, it looks in well-known locations on the machine to figure out which versions of Tickle are installed, and then just has a special semantic to pick the best one. Yeah. Everything has intelligent defaults, and then you're always free to override that type of behavior. So custom commands. So this is the primary purpose of Eagle, was to automate applications, and also originally the primary purpose of Tickle as well. So it's nice because with the minimalist syntax and the custom commands, basically you can create these sort of clean DSLs that have almost no syntax. So it doesn't have to have extraneous, braces or semicolons or whatever. It can just be as simple as command and then arguments. Interactive debugging support. So single step, breakpoints, which you have to actually right now put in the script. I don't have support for just basically dictating it by line number or anything like that. And then also variable watches to break if a variable is modified or accessed. During your interactive debugging experience, you can examine and modify the actual state of the interpreter you're debugging, and it also has a separate interpreter that you can use if you want to test a script and not modify the state of the interpreter you're debugging. And then it's scriptable via the debug command, which has a variety of subcommands. So we have a REPL. And also, while you're in the REPL, there's additional commands which are interactive only. So they only have special meaning to the interactive loop. And then you can figure out what those are by using the help meta command. And also you can get usage information by doing help and then the name. Script cancellation. Oddly similar to tip 285, which I wrote for Tickle.
I got a quick question. Help, like for instance, the help, if I write a custom command, is there any way to denote documentation on that where someone could actually use #help and then my custom command?
Not currently. And I mean, that would only be useful in the interactive loop since the meta commands are only interactive. But I mean, I could add support for that if it was requested. So script cancellation is important for embedding scenarios because if I run scripts that are either marginally trusted or untrusted, I don't want them to be able to monopolize the processor and lock up the application. So I can go ahead and cancel that script in C# using the engine.cancelEvaluate method from any thread. I just need to pass the interpreter in some arguments. And then from a script, I can also basically kill myself by doing interp cancel-unwind, which is not a catchable error. So that unwinds the call stack. And this functionality is, like I said, basically identical to TIP285 that's going to be shipped in Tickle 8.6.
What about just simply providing extra parameters to evaluate no more than 20 seconds?
You can do that too. There's support for timeouts right now in the interpreter object. It starts a watchdog thread that basically just, after it does a wait and then says, oh, cancel evaluate. OK, so variable tracing. So this is interesting because you can do it on a per variable basis or on an interpreter-wide basis. And basically, when somebody accesses the variable or tries to modify it, your C# or VB.NET or whatever procedure will get called. And you can basically either allow them to do that or not, or modify the value that comes back or not. And I actually use this in the core itself to do things like the reference counting. And then also I use it for the env array, which basically has no backing store. Basically, if you do set env temp, it actually just gets the environment variable. So that it doesn't have persistence of that. OK, anonymous procedures. These are compatible with Tickle 8.5, where I stole this feature from. So this is sort of a lambda expression here, the set sum equal to the list of args, which the first argument here is the arguments to it. And args just means it takes a variable number of arguments. And then the second argument is the actual script block to evaluate. And then you use the apply command, passing the lambda expression, and then whatever the arguments are. So this would return 6. And so closures, which are kind of pseudo closures, basically, because the way that it captures the surrounding state's kind of interesting. So you have your same lambda expression here, and then you use the scope command, which basically says, I'm going to create my own call frame that has the name specified by name here. And args means I want to go ahead and capture the formal arguments into that. And basically, this is create or open. So create-open is create it or open it if it's already existing. So if I repeatedly call this, I'll keep getting additional sums onto that. And then I'm saying, oh, if not info exists this variable, then go ahead and create it. And then increment that by whatever they actually went ahead and passed us for the numerical arguments. So yeah.
Quick question. If I don't include that scoping name, is there, like, does it use global state or?
It generates a name for you. If you don't specify the name, it'll give you a generated name.
But if I don't call, like, scope at all?
Oh, then it's just it executes in whatever the scope the current scope is. Okay. The design philosophy of Eagle was heavily influenced by Tickle. Obviously, I stole a lot of the algorithms from Tickle. They've been heavily massaged to sort of fit into the CLR. So it obeys the Endecalogue, which is the 11 syntax rules of Tickle 8.4. Everything is a string. Every command is a string. The first word is the name, and the remaining words are the arguments, if any. Commands are free to interpret their arguments however they wish, such as expr, which interprets it as a mathematical expression. So you can implement many DSLs in a command that way, like the regexp command obviously interprets one of its arguments as a regular expression pattern. But the language itself doesn't care about that and doesn't know. Every list is a string. However, not every string is a well-formed list, and we'll see an example of that in a minute. And the language supplies primitives that can be combined in useful ways. And this comes from the heritage of being a glue language that was sort of designed after Bash and a couple other shell functionalities. There are some differences. Minimal per-thread data. Tickle uses per-thread data a lot. So almost all the state stored in the interpreter object itself. The engine has no state. Most of the public objects that you keep track of have no state. Interpreters may be used from any thread, which is in contrast to Tickle, where they have to be used from the thread they're created on. You can use them from multiple threads simultaneously, and they have no thread affinity. Each thread now has its own call stack and its own current call frame. for a script. But the global call frame is shared, so you can kind of have some communication that way. And finally, there's no interpreter-wide result as there is in Tickle, which merits special attention because it significantly reduces coupling between components, which has been a big problem in Tickle where we had to figure out who didn't reset the result or who changed it. What's missing from the Tickle TK perspective? I mean, you can read this on the slide, because probably people aren't really familiar with that here. Performance. Somebody said that it's not a real talk unless you talk about performance. The Eagle performance is not as good as Tickle, obviously. It can be up to 2 orders of magnitude slower right now, primarily because there's no compiler and I'm not doing any fancy caching or anything right now. I'm only doing the most basic performance tuning. Okay, so let's do the demo. So you'll notice that interactively, if I do something which is success, it actually shows it in green. If I do something bad, it shows it in red. So the interactive debugging support, this just sort of shows the state of the interpreter and the engine and so forth. And like I said, I'd like to integrate this into VS at some point and have it so it's not all console-based. But I haven't had time to do that.
Yeah. No, I'm joking.
Okay. So let's look at some example scripts, I suppose, here. So I should have pre-started this. Actually, let's look at the command example while that's actually starting. So as an example of implementing a custom command, and you know, Eagle can execute arbitrary .NET classes, but the original design didn't call for that. The original design was the commands would implement a well-defined interface, and basically would implement an execute method. They're given the interpreter, and then client data is where you can actually go ahead and pack some state into that. You can pass it back when you add the command to the interpreter. You pass it in, and then it gets passed back to you, so you can transport some state. And then also your list of arguments, and then your result you put in this byref parameter here. I wrap this in a try because commands are discouraged from raising exceptions. I mean, the engine will catch it, but it's sort of better if you don't throw it. So we validate the interpreter, validate the arguments, so basically you don't really want to assume that this stuff that you get passed is valid. You want to sort of try to validate everything. And in this case, we just go ahead and return the first argument. You may wonder why it's index 1. That's because argument 0 is the name of the command as it was invoked, which could be different than what you originally added. So, and then we can return codes.ok. If there's an error, we can go ahead and set the error message and then return codes.error. And so here's an example of using the engine and using the interpreter. I just created a sort of a simple example. So the creation flags, and this pretty much you'll just use this, or I mean, you could just use the default more or less. You need a result object here. And then we go ahead and create an interpreter. And it takes a variety of arguments, including those flags I talked about a second ago. And then in this case, we go ahead and create one of our classes that implements that command. And we add the command. This is where we add the command to the interpreter. And what we're saying is it accepts an I command. And when we created that, we were able to assign it a name here so that we could assign it whatever name we would like. You always want to make sure that your API calls succeed. And then here we go ahead and evaluate a script. In this case, we're just actually executing that command. So let's do that because that's sort of instructive. Actually, okay. Probably want to exit the shell before I recompile. Actually, I want to change the startup project too. Okay, so I go ahead and create the interpreter, which does a whole lot of stuff. Although the startup time is actually not bad. It's actually, normally the shell starts up in a couple seconds. And so the interpreter has a bunch of state, as you can see here. It has a public interface as well that you can access a lot of that state. Then we create our custom class. We add it to the interpreter. That succeeded. Then let's actually go ahead and set a breakpoint in here so we can see what happens. Or whoops, that wasn't what I wanted. Okay, so we have a valid interpreter. We have valid arguments. We have 2 arguments. And then we just go ahead and set the result equal to the first argument and return OK. So that's obviously a trivial implementation of a command. Some of the commands that are in Eagle are significantly more complex. Like there's actually sort of 100 commands at this point, I think. Like the object command. So you're free to look at all the source code later. It's not time to review all of it, but it's all available on SourceForge, or Codeplex, I should say. Okay, so this is an example that sort of automates WinForms, which is kind of cool. So let's go ahead and run that. So I created a form, and if I click the button, it shows it's been clicked. And you may have noticed that it actually displayed that before I clicked it, because I had actually asynchronously scheduled that click event to be called. I'll show you what I did for that. So this handle click event here, as you can see, is just a script, and it's taking 2 arguments, which should be familiar to people that have used .NET. We go ahead and import WinForms here, and then we create a form, and we alias it so we can just go ahead and use that as a command. So we set the caption and set it to topmost, show it. We create a button, we sort of center it, we set the button text. This is the interesting part here. This is where we call the framework method to add this click event that basically, the argument to this is just an arbitrary script. And what happens is the engine will evaluate whatever this is and then append the two arguments to it, append sender and E to whatever that is. So it doesn't have to be a procedure. It could just be an inline script as long as it's designed in such a way that it can accept 2 additional arguments at the end. So it's very loosely coupled. And then we go ahead and add the button to the form here. And then we just do some, we basically set the interval between processing of the events, and then we schedule, this after command basically schedules the script to be run in the future, in this case in a 1/10 of a second. And then we actually fake up an event, we fake up a mouse event args and basically simulate the user clicking it. I stole this from the unit test suite. But the idea is that we want to simulate an event without the user actually clicking it. And then vwait just basically says, keep processing events until this variable changes. Anybody have any questions so far? How much time have I got left? 1 minute. Any questions?
So you said this is open source. Where can we?
Yeah, you can download it from eagle.to, or you can also get it from eagle.codeplex.com, which is the. Oh, yes.
Yesterday you were talking about the ability to restrict.
Oh yes, the execution policies. So the way that works is, if the interpreter is marked as safe, the commands that have an attribute, there's an attribute that you put on the command that indicates it's unsafe. And then those commands will be hidden in a safe interpreter. And when the engine detects that you're trying to execute a hidden command, it actually goes ahead and tries to execute the security policies in the interpreter and see if one of those policies will approve the command for execution. It's based on the arguments that they passed, and there's other context that's provided so that they can make an intelligent determination as to whether it should be allowed or denied. Okay, looks like I'm done.